It's time to talk about linear searches. Now, a linear search is not too different from a binary search in that it is a method for finding a target value within a list. However, the big difference is that it's much less efficient because it checks each element of the list for the target value until a match is found or until all the elements are searched. So there's no elimination of half of the array and then searching just a portion of it. It checks every single slot. And so that's why it's a lot less efficient. If you look at this image here, we're looking for the number 5. And so we can start at the index of 0, but we have to check the slot that contains 10 and then 8, 1, 21, 7, 32 until we reach 5, and then we can stop. And it's important for you to know about linear search because of its inefficiency. So that's something that can come up in an interview question regarding algorithms where they propose some type of linear search, but really you want to try to think of the most efficient approach, so it would not be the best answer to come up with an algorithm that uses linear search, unless you absolutely had to and sorting is not available and you have all these other limitations and then you're forced to use it. But it's good to know that, whether you're in an interview or you're just working on building an application and you need to decide whether or not this is an option to use. This is an algorithm that is highly affected by the amount of input. If you have like 1 million numbers that you're going to traverse through, it's going to take a lot longer versus if you used a binary search. Let's go ahead and take a look at some pseudocode to see how we would implement this. Now, if we had a function called linear search, the inputs and outputs are similar to the binary search, where A is the array to search inside of and X is the value that we're searching for. And the output is where the index position is where our array A with the index position of I is equal to our value. Or it's a -1 that we return because we did not find it. So in our steps, if we have a variable called answer, we're going to set that to -1. We are essentially starting from the 0 position. And then moving on to step 2, we are moving and iterating all the way through n. That is for each index I going from 1 to n, which is the last index position of A. I will keep getting incremented, and if during the loop we come across what we're searching for, we assign the value to the variable answer. If not, we return -1. Let's go on and write some code to implement this.